Why use square roots when factoring perfect square trinomials? Imagine trying to solve a puzzle where you need to find pieces that fit perfectly together. When working with perfect square trinomials, square roots are like your puzzle-solving tools. They help you see the hidden connection between the parts of the polynomial. Perfect square trinomials are special because they come from squaring a binomial, which is a simple expression with two terms. These trinomials have three terms, and their structure is very specific. The first and last terms are perfect squares, and the middle term is twice the product of the square roots of those first and last terms. Using square roots makes it easier to identify the binomial that was squared to create the trinomial. For example, if you see the trinomial squared plus 6x plus 9, you can recognize that x squared is the square of x, and 9 is the square of 3. This tells you that the binomial was x plus 3, or possibly x minus 3, depending on the signs. To confirm, you check if the middle term matches 2 times the square root of the first term times the square root of the last term. In this case, 2 times x times 3 equals 6x, which matches the middle term. Once you confirm this, you can rewrite the trinomial as a perfect square binomial squared. It becomes either x plus 3 all squared or x minus 3 all squared. This process simplifies the task of factoring because, instead of trying many different factors, you directly use the square roots to find the binomial that was squared. This makes the process faster and clearer. Factoring perfect square trinomials with square roots is especially helpful when solving quadratic equations. It allows you to quickly rewrite the equation in a form that is easy to solve by taking square roots. It also helps in graphing parabolas because you can easily find the vertex of the quadratic function. In short, square roots are essential because they reveal the binomial components that created the trinomial. Recognizing these components makes factoring more straightforward and helps you understand the structure of the polynomial better. This approach is a key step in building confidence in algebra and solving more complex problems down the line.